Okay, so we have the motors installed. We got banana couplers here so that if we blow a motor we can easily replace it, not so much on the fly, but easier than cutting and resplicing. Another connector. These have been soldered onto the motors with little pigtails to the banana connector. Care must be taken when installing them to make sure that both motors are turning in the same direction, as so that the tires aren't trying to oppose each other when driving. They don't look too big in here, but they are a little bigger than the 500 motor series, right? These are 775s. So a little more research states that the overall top speed isn't going to increase drastically. Like the gearing hasn't changed over too much, but the torque has increased greatly. So that means that going up hills or off the line, you get a higher torque ratio. And then what you have here is a bigger motor, which when we upgrade to the increased voltage is going to be able to withstand the heat and maybe dissipate that heat a little better than the smaller motors, because it won't be working as hard, or it's got a lot more windings and such to absorb that type of energy. Alright, so what we're going to do now is we're going to do a couple RPM tests, right, or tachometer tests. I got a tachometer. What we'll do is we'll put some indicators on the tires, and what I have is a stock Power Wheels setup, and then I have this setup here with the 775 motors. And what we'll do is we'll do a quick analysis of the RPM that the tire is turning through the same diameter tire, so it will give us increase in the speed, or if it's going to be the same speed, just the motors may last longer without burning up under the increased voltage. Okay, and what we have here is this is going a little handheld, so sorry about being shaky, but these are the stock motors, and I don't know if you can tell because they're not in direct comparison. We'll try and do that later. How much bigger the new motor is, or if it's focusing in there, right? It's hard to tell from the monitor. But there's the stock motors that we'll be comparing the RPM ratio to the modified Hot Wheels. See, there's no banana clips. It's all stock wiring, stock motor connections, etc. Okay, so what we got here is we have a reflective adhesive piece of sticker that's going to interact with this laser tachometer or RPM sensor, okay? And I've already done it, but I'm going to show you guys how I did it, and then we'll read the numbers. So this is going to be stock battery, 12 volts, upgraded motor, 775s, but with unknown specs when I bought them off the internet. So we'll see on low gear what the RPM is for this setup. Okay, so we got approximately 63 RPMs under the low setting, which I don't know if that's exactly 6 volts, how it works with the 12 volt wiring harness, but we're getting 63 RPM in the low gear. Now we'll switch to the high gear, which is going to give us full power, and we'll see what the revolutions per minute or RPM is under that setting. Okay, and we got approximately around 97 RPM. So this is the stock motor or not the stock motor, the stock battery setup, but not the higher voltage. So after I do the stock car with the stock motors, we'll put in 24 volts and see what the setup, what changes there. Okay, so we can see we're at the other car. We have the reflective adhesive sticker set in the same spot, just one. Sometimes if the diameter of the wheel and the RPM is too slow for the tachometer, or to get a more accurate reading, they suggest putting multiple reflectors on there than dividing by the amount of reflectors. And this just gives the monitor something more accurate to read from. But we'll see what it does. We're going to go start in the low gear, stock gears, 12 volt stock power, and we'll see what we're getting for RPM. Okay, we're getting about 66 RPM. Okay, so now we shifted into high gear, stock 12 volt battery, and we'll see what the RPM rating on that is. And we're getting around 140, 141 RPM. Okay, we're now set up under the 24 voltage system, and we're going to see how these motors are performing with gear ratios. We got approximately 126 RPM. Okay, now we'll switch it up to high gear, and we'll see how it performs under full 24 volts. Okay, we're going around 189 RPM. Now mind you, these are all not under load, right? Like there's no child in there, so it's not going to be, the motor would affect differently under loaded conditions. So now I'll set up to 24 volts in the stock motor car, and we'll see what the results are with that. Okay, so I got the stock system powered up. I have to switch between vehicles. I don't have all the wiring set up for to run all 2 or 3 of my units at 24 yet. That's going to happen soon. Okay, so let's see. This is going to be low gear, stock motors, 12 volt. No, 24 volt. I'm sorry, 24 volt stock motors. Okay, it's around 130 RPM on low. We'll switch her up to high gear, and we'll see how it performs. Okay, 247. So we're getting some different numbers there, and what I'll do is I'll put it on a chart. I also have a quad, a Kawasaki quad that I've done the RPM test on, just under 12 volts. And we can compare the 12 volt model, and then if I want to do the 24 volts before I do the board, I may do that. Then we compare all three and see if different units have different gearings or different motors. I know sometimes they do throw different motors or gearing in different units as they're geared towards maybe older or younger children, or on-road terrain versus off-road terrain. So we'll check that out. Okay, so what I've done is I've got our results, and I've marked them up on a board. The board on the left is 12 volt, board on the right is 24 volt. The low low gear seems to be pretty close. It seems to be within 5 on the high and within 2 in the low. So I'm going to call that negligible or the same, right? Like the equipment I'm using, the tachometer I'm using, none of this is precision. But when we get up to the high gear, under 12 volt there, we have 45% more RPM in the stock motor, which we'll get into. And in the 24 volt, once again, it jumps up a little bit because you're going to more voltage to 57%. So why is that? Well, let's take a closer look at the motors there, and you can see the modded motor is a lot bigger, so it should have more torque. Now what happens is Power Wheels buys good motors for their units, which are custom made for their Power Wheels units. So they'll pay very low dollar amount for a high quality unit because they buy mass quantities. Now the motor on the right, the modded unit that I bought, of course being kind of like on the cheap and just kind of experimenting, I bought off of the internet at I believe it was around $10 a motor, and I thought that was a great deal. So once I got it shipped in and I bought the motor, I thought, oh, what a good deal. But what happens is that motor possibly has less windings or turns. It does have good bearings and bearing surfaces, which I've noticed, which I'll get into a little later in the video. But that possibly comes into effect with the percentage difference under the high gear difference in RPM, which maybe I will cut one of those motors open and we can do a comparison of the two once I burn one out, or my son burns one out, and we can look further into what's going on. I will post the findings from the third unit. These are 2 stock car units, and I do have a quad which I showed earlier, and I will post that one in comparison to these. Okay, so what we're going to be testing now is the stock quad drivetrain with 24 12 volt setup, and we'll see that the gear ratio is on this, and then we can do a couple estimates on which one will be quicker. So this is going to be on the low setting. Got around 140 RPM. We'll set up to high gear now. Around 248 RPM. Okay, so for the modded motors, it's in the Lowe's 48 Jimmy Stewart car. The stock motor with same gear ratio as the Lowe's is Lightning McQueen, and then the last edition is the little Kawasaki motor with the bigger tires. So I did the RPM on that one, and what we have is on low gear we have 140 RPM, and then on high gear we have a 248 RPM. So you can see how that is kind of similar to the stock one. But once again, what we have to do is see if the torque ratio is going to change once we have the kids in them, and then we'll see which one's quicker off the line, if it does translate into more top end, or if it changes when the kids are in them, if the weight affects the way the motor is able to pull. So we have underload and not underload. So we'll check that out next.